What's up, everyone, and welcome to the 100 linear equation live stream. So I'm going to be going through 100 linear equations. So this is the most questions I've ever done in one live stream. And just so you know, I wrote it above, but you could click the link in the description below to get the 100 questions in PDF form. I shared it on the Vinteachers Math Google Drive. So you could get it as a PDF if you want to follow along. The questions will start off not so bad, and then they're going to pick up in difficulty as we go. All right, so let me, we will get this going here. So just making sure everything is on silent here. And yeah, let's get rolling here. So first up here, 5 times x equals 10. So we'll start off nice. So when we want to solve for x, so every question here, we're solving each equation for the variable x. All right, so that is the objective for all of these questions here. So we want to get rid of this 5. It's attached by multiplication. So the opposite of multiplying by 5 would be to divide by 5. But remember, the golden rule of algebra is whatever you do to one side of an equation, you have to do to the other. So, good morning. Was it Alicia Nelson? Good morning. Ryan Tube, good morning. Yes, from the geometry stream. The Regents was very easy. You wrote all your answers in the list part of your calculator to compare later on. Very nice. So, yeah, I know you were going for the 100. That's like a pretty ambitious, take. But I'm rooting for you, Ryan. There's definitely a special place in this world for people who are like that level of perfectionist. So, don't lose that standard for yourself. That's going to definitely lead to a payday. So here, 5x equals 10. We're dividing both sides by 5. The 5 over 5 is going to cancel. And then we just have here x left on the left. And then 10 divided by 5 here is equal to 2. Okay, so that's our first question done. So now 99 to go. But don't worry, I'm not going to count down. If you want to count down in the chat, by all means, go ahead. So now let's say for the first few questions, they're going to be one step to solve. And then they're going to pick up and be like more than one step and get more complicated as we go. So now we have x over 5, or x divided by 5 equals 4. So here, there's a few different ways we could solve this. But when you have x divided by something, the opposite of dividing is multiplying. So for this one here, to get rid of that divide by 5, I would multiply by 5. But whatever I do to the left side, I have to do the same to the right side to keep that equal sign strong. So now 5 times x over 5, the 5 over 5 will cancel. And now we're going to have x is equal to 4 times 5 is 20. Okay, so x equals 20 is our solution to the second question here. All right, so moving on. And, just to make it more formal, what I'll do is I'll just go ahead and circle all of our answers. So x equals 2 was the answer to the first one. And now x equals 20 was our solution to the second one. So now something very similar here. For the next question, we have 1/3 x equals -6. So to get rid of this 1/3, it's 1/3 times x here like this. There's a few ways we could do this. You are able to divide both sides by 1/3, but I would say here a nicer way of doing this is just to multiply both sides by 3. Okay, so a little idea for solving linear equations is that you could multiply, so you could multiply both sides. So this is just to be, sort of instructional here. Multiply both sides by the reciprocal. So reciprocal of x. Okay, so right now we have a 1/3 in front of x. So we multiply both sides by the reciprocal, which would be 3 over 1 or just 3. So that's like one step to do this. And then 3 over 3 cancels, and we have 1x or just x is equal to -6 times 3 is -18. All right, now just know, with this same exact question, you could have divided both sides by 1/3. That also works. That's fine. But then you'd have to know the keep, change, flip technique. Okay, so keep, change, flip. You keep the top expression here, the -6. You change the operation from division to multiplication, and then you flip the bottom fraction to 3 over 1. And in either case here, you're still going to get -18. All right, but I just like to do this. Multiply both sides by the reciprocal. All right, which leads into the next question here. Once again, I could divide both sides by 4 over 7, or I can multiply by the reciprocal 7 over 4. All right, now a little trick. So 7 over 7 cancels, 4 over 4 cancels, and now we have x equals. So some people might go through the trouble here of doing, all right, 32 times 7 and they get 14, carry the 1, they get 224. And then they have to do 224 divided by 4. That's a lot of extra work. What I like to do in situations like this is I do 32 divided by 4 is 8. And then 8 times 7 is 56. Okay, because if you do it the other way, once again, if you do 32 over 1 times 7 over 4 like this, I just separate this here. 32 times 7, we just saw, is 224. And then we divide by 4. This will work. But then you have to do, on the side, you have to do 224 divided by 4. And that's a lot of extra stuff to do. So then it goes in 5 times. You subtract the product, 22, carry this down, you get a 4. And then 4 goes into 24 6 times. So I personally like to cross cancel when I'm multiplying a whole number by a fraction. So 32 divided by 4 is 8, and then 8 times 7 is 56. This, I think, is the way nicer way of getting there. Okay, but you can do the long stuff over here, but, make life easier for yourself. All right, so now moving on. Question 5. So, all right, we still got plenty of questions to go. So now, one step here, adding and subtracting. So we have x plus 4 equals 12. The opposite of adding 4 is subtracting 4. So I would do minus 4 on both sides. And now 4 minus 4 cancels, and you're going to have x equals 12 minus 4 is 8. Okay, so question 5, you're going to have x equals 8. Let me just make sure. Yeah, I did circle or box off the answer to the last one. So here, yeah, it's pretty straightforward. Just subtract on both sides to get rid of the plus 4. Now, this sometimes throws students off. Like, let's say instead of x plus 7 equals, we have something like 7 plus x equals. In a situation like this, just know the opposite of positive 7 is negative 7. So you do minus 7 on both sides. And it's still going to have the same effect. 7 minus 7 is going to cancel. And you're going to have plus x, or just x, is equal to negative 2 minus 7 is negative 9. Now, some students struggle with the integer part of things. Just know that in my head, when I'm doing minus 2 minus 7, I'm really just saying negative, and then I'm doing 2 plus 7. Okay, because when you have like a negative and then minus, some number here, this, in a situation like this, when I have minus like this, I just do negative, and then 2 plus 7 is 9. So that's how I'm getting negative 9 in my head. So just be careful with the integer stuff, because that's a common thing people struggle with when they're solving linear equations, is the integers. Okay, so just be really comfortable with adding and subtracting integers. So now, how do we deal with subtraction? So the opposite of subtracting is adding. So to get rid of the minus 6, we would do plus 6. So plus 6, and now minus 6 plus 6 cancels, and we get x equals 13 plus 6 is 19. All right, so once again, yeah, these questions start off easy because we got to build some confidence. And then they're going to get a little bit ridiculous as we move on. So this is a nice warm-up. Now, I could also explain why am I doing this. I'm trying to model for my students the value of practice. That, if you really want to be sharp, I mean, I'm not saying do 100 questions every day, but sometimes just sitting there and just grinding through a bunch of examples could really sharpen you up. And you getting good at this will make geometry easier, will make advanced algebra 2 easier. It'll make pre-calculus easier. It'll even make calculus easier, because believe it or not, algebra is going to be there with you for the rest of your math that you're doing. Aside from heavy statistics classes aren't super algebra heavy. It's more reading and, reading comprehension. But for the technical math classes, your algebra has to be strong. So this is something good for you to do. So now minus 5 plus x equals minus 30. To get rid of that minus 5, just do plus 5. Okay, so the first thing you have to do when you're doing linear equations is master the one step to solve equation. Okay, so negative 30 plus 5 is going to give us negative 25. So in a situation like this, honestly, when the numbers have different signs, like when I'm doing negative 30 plus 5 in my head, I know the answer is going to be negative, and then I just do 30 minus 5 in my head. Okay, so it's I take the negative out and I do 30 minus 5. That's how I'm getting negative 25 so fast. So one of the most important prerequisite skills you need to be good at solving linear equations is integer operations. You have to be really awesome at integers. So it takes time, but you can get good at it. All right, so moving on now to question 9. And of course, if anyone spots, if I say something silly at some point and make a mistake, I'm going to do my best not to. But let me know. I did go over these questions and check them all ahead of time, so that this is as airtight as possible. But if I say something out of place, that's why the chat is there. All right, 6x plus 7 equals 55. So now the two-step to solve equation. So you could divide by 6 first, but I don't recommend it. That's going to make life definitely tougher. I recommend getting the constant to the other side first. So to get rid of plus 7, do minus 7. Okay, and now 7 minus 7 cancels. You have 6x equals 55 minus 7 is going to give you 48. And now it's back to the one step. So 6 times x equals, you divide both sides by 6. Okay, and now x equals 8. Remember, the game here is doing the opposite operation until you get x by itself. So once there's more than one step, it gets slightly more complicated. Okay, until there's like many, many steps, then you really have to, think carefully. So question 10, 8x minus 7 equals 17, or you could say it backwards, 17 equals 8x minus 7. So that minus 7 is the first thing I want to move. I'm going to do plus 7 to both sides. Okay, so these cancel, and 17 plus 7 is 24, and now this is equal to 8x. So then divide both sides by 8. Okay, and now you've got x equals 24 divided by 8 is 3. All right. Now, one thing, I haven't been doing this for the questions, but if it were a test setting and you have time, checking your answer isn't the worst thing, to do. You have 8 times 3 minus 7, and you could even ask yourself, is 17 equal to 8 times 3 is 24 minus 7? 17 equals 17 checks out. So x equals 3 is, in fact, our solution. So that's like something I do in my head if it's doable within the time given to us to make sure that we're doing these right. But if I do 100 questions and check 100 questions, that's going to take forever. So I can leave that up to you, like as you're watching this. All right. So now we have 9 minus x. 9 minus x is equal to 7. So for this one, the minus x throws students off, like when I see students do this. But don't worry about this. I would get rid of that 9 first. I mean, I'll show another way to do this in a moment. Like I'll just let me make that a better line. That wasn't my best line I've ever drawn. That's a better line. Here. Okay, one way of doing this is just say minus 9 on both sides. And now 9 minus 9 cancels. So this cancels out. And now you have minus x equals. The most common mistake here is people just say x equals. They forget to bring the minus with it. And 7 minus 9 is negative 2. And then divide both sides by, let me just make that neater. The coefficient here, if it's minus x equals, there's an invisible 1 here. So you could divide both sides by negative 1. And then that'll turn this into just x equals, because a negative divided by a negative is positive. Okay, so just imagine here there's a negative 1, like these just in a sense cancel out. And you have x equals negative 2 divided by negative 1 is positive 2. Okay, so question 11 should be x equals positive 2. And you could even see here, the original equation was 9 minus x equals 7. So if I did 9 minus 2 equals 7, 7 equals 7, it checks out. So these, like some of them you just do in your head. Now, I'm just going to show one more way of doing this. 9 minus x equals 7. Some people might opt to do this. They might say plus x on both sides. And then this says 9 equals x plus 7. And then they go minus 7. All right, this is also fine, because it's also 2 steps. So either way, you're going to get x equals 2. So you decide which one you'd rather do. All right, question 12. Something very similar, 15 minus x equals 3. This one we'll just solve one way. We'll subtract the 15 on both sides. 15 minus 15 cancels. Minus x equals 3 minus 15 is negative 12. And then divide both sides by negative 1. Okay, remember, there's an invisible 1 here, so these cancel, and you get x equals positive 12. Okay, so just making sure our answers are in fact good so far, and all of them are. Cool. So moving on here, let's see, question 13. Okay, 11 equals 15x plus 16. So this one, I would move the 16. So we're mastering now the 2-step equation. So 11 minus 16 is negative 5, because 11 and 16 are 5 away from each other, and the bigger number has a minus attached. So that's how I know it's going to be negative. And this is equal to 15x. So now divide both sides by 15, and oh, there we have it. Our first answer, that's not a whole number. It's going to be a fraction answer. So here, don't leave your answer as negative 5 over 15. Most teachers are going to want you to simplify. So notice the top and bottom have common factors of 5. So I would divide the top and the bottom by 5. Okay, and this will tell us here that x equals -5 divided by 5 is -1 over 15 divided by 5 is 3. Okay, so x equals -1/3 would be our answer. One thing to point out here, like let's say, your like fraction game is, needs work here, needs improvement. Just know that it is an option if you are allowed a calculator. You could do something like -5 over 15. You just press enter, and if you have a TI 84, you could press math and then enter, and it'll reduce the fraction for you. Okay, so that's an option for questions like this. But I'm going to do basically all these questions without a calculator, but occasionally I'll bring it in to do like some crazy multiplication or division. All right, 6x minus 1 equals 11, so 2 steps. Add 1 to both sides. -1 plus 1 cancels. 6x equals 11 plus 1 is 12. And now divide both sides by 6. And you've got x equals 2. All right, so x equals 2. All right, moving on here. Question 15. The beginning, it goes fast, but then these are going to slow down. Okay, this is going to definitely take me a while. -8 minus x equals -10. So this, I would get rid of that plus. I would do +8 to get rid of that -8. Okay, so like this. And now -8 plus 8 cancels. We get -x equals -10 plus 8 is -2. And now remember the invisible 1. We're dividing both sides by -1. Like this. Okay, so I'll put the 1 here. This cancels. X equals +2. Okay, so 15 is +2. Just know there's another way of doing this. -x minus 8 equals -10. You could, and this is nice notation that we're allowed to use. That was not my best line. Let's try that one more time. Okay, that's a little bit. Oh, wait, I could adjust it as we go. So let me move this a little bit over here. Is one move you're allowed to do in algebra is you can multiply everything by the same number. And if I put parentheses around the entire equation, that means multiply everything in the equation by, in this case, -1. Because if I do -1 times -8, that's +8. -1 times -x is +x. And then -1 times -10 is +10. And then you see here, just go -8. So this is also a nice way to do it. Either way, x equals 2. But there'll be more later. I'm kind of jumping ahead by doing the distributive property now. Distributive property is going to show up a lot later on. All right. So looking at 3x over 8 equals 12. So remember what I said before, within the first 5-ish questions or first 10 questions, multiply both sides by the reciprocal. So I would multiply the left side by 8 over 3. And whatever I do to the left side, I have to do the same thing to the right side to keep that equal sign strong. 8 over 8 cancels, 3 over 3 cancels, and we're left with just x. Equals, and now I could do 12 times 8 is 96, or I could do 12 divided by 3 is 4. And then 4 times 8 is 32. Okay, so 16 should be 32. All right, cool. I like the cross-cancel method. All right, I do prefer that more. So let's go back and practice keep, change, flip. So this one here, I'll divide both sides by 2/3. Okay, so 17, we are, we're dividing both sides by 2/3. Okay, and 2/3 over 2/3 cancels. X equals, and now we're going to keep, change, flip. Keep the top as -8. Change the operation to multiplication and flip the bottom to 3 over 2. And now this is going to give us x equals, if you want to do it the other way, you could do -8 times 3 is -24, divided by 1 times 2 is 2. And this will tell you that x equals -24 over 2 is -12. Okay, so 17, you should have -12 for that one. All right, moving on. So anyone who's watching right now live, once again, thank you for joining and supporting this live stream. I am going to post this video afterwards because I just thought it'd be a fun video to make here to, go through all this pain and suffering by doing 100 questions. So 18, we're making some progress here. So 3/4 times x, sure, we'll do the keep, change, flip again. Divide both sides by 3/4. And now 3/4 cancels like this. And we've got x equals, and now working this one out, we have 12 times, remember, keep, change, flip. So from here to here, we're doing keep, change, flip. 12 times 4/3. And now 12 divided by 3 is 4, and 4 times 4 is 16. So x equals 16. Okay, so 18, we should have 16. All right, 9x over 5 equals negative 18. So for this one here, we'll multiply both sides by the reciprocal, 5 over 9. Okay, so 5 over 9 on both sides. And now we just cancel out. 5 over 5 cancels, 9 over 9 cancels, x equals, and I'll do the cross cancel method. 18 divided by 9 is 2. And now negative 2 times 5 is negative 10. So question 19 should be negative 10. All right. So this one here, there's a few ways we could do this one. Multiplying by, let's see, what's the best way to do this? All right, so now we have a proportion to solve. We could cross multiply. You could do that, or you could even multiply by the reciprocal. All right, so maybe this one will solve both ways. If we cross multiply, we're going to have 5x times 2 is 10x equals 4 times 45 is 180. Okay, if you lift weights, any weightlifters out there, you know the 45-pound plates. If you have 4 of them, you have 180 pounds. All right, so 5x times 2 is 10x. 4 times 45 is this. Now divide both sides by 10. And 10 divided by 10 cancels. X equals, nice little trick. When you have common zeros trailing the numbers, you could cross them off. And then 18 over 1 is 18. Okay, so this should be 18. Another way, 5x over 4 equals 45 over 2 would be to multiply both sides by the reciprocal. So you could do times 4/5 on both sides. And then 4 over 4, 5 over 5 cancels, and x equals, and now cross cancel, 45 divided by 5 is 9, and 4 divided by 2 is 2, and then 9 times 2 is also 18. Okay, so either way, you get 18, but it's up to you to decide which one you think is easier. All right, so now, more situations like this. So here, just divide both sides by negative 3/5. Okay, or multiply by the reciprocal, either way. X equals, keep, change, flip, 30 times the reciprocal here, 5 over negative 3. Now, one thing to point out, just know this about fractions. Negative 3 over 5 is the same thing as 3 over negative 5. And that's the same thing as negative and then space 3/5. Okay, you could write a fraction 3 different ways when there's a negative involved. And these are all equivalent. So don't get so caught up over this negative here. It's not like too big of a deal. All right, so now for this one, you have 30 divided by 3 is 10. And now what we have is this is equal to 10 times 5 is 50. And just think of this as 50 over the negative. There's a negative 1 left on bottom, which will simplify to negative 50. Okay, so if you even want to write a 1 here as a placeholder, you can. But in either case here, x equals negative 50 is our solution to question 21. Okay, so very cool. Moving on. All right. So question 22, 7.2 equals 4 over 5 times, or 4x over 5. So this one, I'm multiplying both sides by the reciprocal, 5 over 4. Okay, so times 5 over 4. Now, you could use a calculator here, which we'll do in a moment to check this. So in a moment, we're going to say x equals 5/4 of 7.2. So this is definitely a calculator situation, but why not learn a little mental math here too? What I'm imagining in my head, if you want to do this in your head, is I imagine 72 divided by 4. And when I divide something by 4, I divide it by 2 twice. So I do 72 divided by 2 is 36. And then 36 divided by 2 is equal to 18. Okay, so then here I would have 18, but the thing is 7.2 divided by 4 is not going to be 18. Okay, 72 divided by 4 is 18, but 7.2 divided by 4 would be 1.8. Okay, but then you could even imagine here, I'm doing 1.8 times 5. That is a lot like saying 18 times 5. And 18 times 5 is 90, but now with a decimal there, it'll be 9.0. Okay, so here 1.8 times 5 is 9.0 or just 9. All right, but once again, if this were a, high school math class or college math class, and they're like, hey, you're allowed to use a calculator, there is no shame in typing this in. Okay, if you try to be too heroic, it could throw you off. So let's just see here how I would do this. You could press alpha y equals enter if you want to pull up a fraction and write 5/4. Hit the right arrow to get out, and then times 7.2. Okay, and it'll just give you 9. All right, or you could even just say 5/4 in parentheses, and you could put 7.2. You could put 7.2 in parentheses like this. Okay, just to multiply this out, and you also get 9. All right, so there's no point in struggling with the mental math, but I like to, when I teach in person and online, show a little bit of like what's going on in my head when I do these in my head. All right, but oh yeah, water lyrics, answer 9. I'm glad you are following along, that we have people doing the math with me. So awesome. So question 23, 2 steps, -1 on both sides. 3x equals 18. Now divide both sides by 3, and x equals 6. All right, 23 is pretty straightforward. All right, here we go. Now we got some slightly funky ones. Now this you could do a few different ways, but let's first just go this way. -9 on both sides. That gets rid of this. And you get x over 5 equals 7 minus 9 is -2. And now to get rid of divide by 5, you're going to multiply both sides by 5. So this, we have x equals -10. Okay, so 24 should be -10, and it is. Okay, now the second way of doing this, x over 5 plus 9 equals 7. This way is, I want to say more advanced, but I think of the least common denominator. These all technically have a denominator of 1. So you have between 1 and 5, the least common denominator would be 5. If you multiplied everything by 5, okay, this would give you 5 times x over 5. So like I'm distributing this through. Let me draw that second arrow a little neater. That was not my best arrow. 5 times 9 is 45 equals 5 times 7 is 35. And then 5 over 5 cancels. So you have x plus 45 equals 35. And you can subtract 45 on both sides. All right, so the benefit of this method is that by multiplying by the least common denominator, everything you multiply by the least common denominator, it gets rid of all the fractions and it turns it into something nice like 5x plus 45 equals 35. So some students, like, they really just despise fractions and they really like to do it this way. All right. Oh, 25 is, oh, so this is, oh wait, 25 is 9. Let me see. I think, where are we? We'll see what 25 is. I think 25 worked out to something different, unless you're saying something else. Let's see. So -3 on both sides. And 3 minus 3 cancels. -2 minus 3 is -5 equals x over 6. And now let's make that 6 a little bit neater. To get rid of divide by 6, multiply both sides by 6. So I'll put this in parentheses and say times 6 on this side. And now 6 over 6 cancels. X equals 6 times -5 is -30. Okay. If we want to check our answer, because in the chat I see we put -9 for a moment. But if it's like, uh-oh, like, am I correct? Or, who's right here? Remember, you could always check your answers to these. So if I'm claiming the answer is -30, then I'm going to write alpha y equals enter. -30 is my numerator for x, divided by 6. And then I exit and write +3. And see how it gives me -2. All right, so I'm feeling good about that answer to the previous one. All right, so now fractions and mixed numbers. So here, this one actually works out fairly nice because when we add 1/2 to both sides, one thing I'm imagining here is just know 17 and 1/2, that's the same thing as 17 plus a half. So if I have 17 and 1/2 plus a half, that's 17 plus a half plus another half. And then this works out to 1. 1 half plus 1 half is 1. So that's 17 plus 1, which simplifies to 18. Okay, so after this cancels, we have 9x equals 18. And then you divide both sides by 9, and x equals 2. Okay, so x equals 2. All right, cool. Oh, so at Water Lyrics, it's all right. It happens. Remember, the theme is like, in math, you're never going to be flawless. But when you practice, it's almost like you're supposed to get questions wrong when you're practicing. Like, that's what the point of practice is. Like, you're not like you focus, but it's more like a relaxed, like casual state when you're practicing. When you're at test mode, building up to a test, you get more serious. Like, you're like, all right, let me really get in the zone here as I prepare for this test. But otherwise, like leading up to the test, for the most part, it's like your practice should feel somewhat light. All right, so we're subtracting 0.2 on each side. So minus 0.2. And I'm going to rename this as 5.0 because then in my head what I'm doing is I'm doing 50 minus 2 is 48. Okay, but instead of 48, it's going to be 4.8. So this cancels, and I have 4x equals 5 minus 0.2 is 4.8. Okay, it's a lot like 50 minus 2, except, there's decimals involved. So now divide both sides by 4, and we've got x equals, and then the next thing I'm thinking of is 48 divided by 4 is 12. So if I put a decimal in the middle, then I have to put a decimal in the middle here, and it's 1.2. So 27 should be 1.2. All right. X equals 1.2. So at Umar, very nice. Cool. Oh, we have people solving with us. Very nice. I'm glad you're all joining me. This is nice. Practicing in August. So let's see here. So plus, let me just click this on silent here. Okay. Spam anyway. All right. So plus 0.2 on both sides to get rid of that minus 0.2. And now this part here is going to cancel. 4 plus 0.2 is 4.2 equals 3x. And now divide both sides by 3. X equals, this reminds me, 42 divided by 3 is 14. Okay, so 42 over 3 is 14. So put a decimal here, and you put a decimal here. So it's 1.4. All right, so two-step equations, but now with decimals and fractions. Fractions tend to upset people. Minus 8 on both sides, so this starts nicely. And now we have 1/4 x equals 5 minus 8 is negative 3. And then we're basically, to get rid of that 1/4, a few ways to do it, but we could just multiply both sides by 4. Okay, 4 over 4 cancels, and we'll have x equals negative 3 times 4 is negative 12. Okay, so 29 should be negative 12. Okay, question 30. So we are 3/10 of the way there. Yeah, and as these questions take longer, it's like, it seems like, wow, you're going to be done so fast, but this really does take a long time. So minus 5 on both sides. And now 5 minus 5 cancels. 17 minus 5 is 12. And that is equal to negative 2/3 x. And now from here, we could divide both sides by negative 2/3. Okay, so I'll cycle between multiplying by the reciprocal and dividing. So we could see the keep, change, flip method and also the multiply by the reciprocal method. But remember, when you're doing keep, change, flip, like here we have 12 times the reciprocal is 3 over negative 2. You're basically doing keep, change, flip. Like you're multiplying by the reciprocal. So that's why I like to multiply both sides by the reciprocal, because it skips a step for keep, change, flip. It just basically gets the job done faster. So now 12 divided by 2 is 6. Okay, so 6. And I'll put a 1 here as a placeholder. And now we have x equals 6 times 3 is 18. And we're dividing by negative 1. So this tells us x equals negative 18. Okay, so 30 should be negative 18. All right, moving on. Question 31. So let's see. Negative 12. Wait, negative 12 you got for question 30? Yeah, that one should be negative 18. Yeah. Because even if you check here, 2/3 of 18 is 12, but it'll become plus 12. 5 plus 12 will give you 17. Oh, thank you for subscribing at Water Lyrics. I really appreciate this the subscription. So thank you so much. Yeah, it's I really mean it when I say it. The live streams are my favorite days on YouTube. So I just like being able to like look at the chat and talk with all of you and stuff. Like responding to comments is nice, but when it's live, it's like there's a back and forth that's like really cool that you don't quite get when you're just making the videos. I love making the videos too, don't get me wrong. But the live streams are like definitely my favorite days because I get to, talk back and forth with all of you. So thank you for being on here and supporting the stream. Oh, Ryan Tube 31. So let's see. How's Ryan Tube doing here? I have faith in you, Ryan Tube, because if you said what, you got a 95 on your geometry regents and then you were going to take it again for the 100. So something's telling me that you really know your algebra. So let's see. So 49 minus 9 is 40. And then we can multiply both sides by the reciprocal of x. So we just flip the 4 over 5, and that's what we're multiplying both sides by. And 5 over 5, 4 over 4 is gone. X equals 40 divided by 4 is 10. And now we have 10 times 5 is 50. So yes, x equals 50. Very nice. Stay strong. Yeah, I'm trying to sharpen up too because school for us starts, I'm in New York, it starts in 2 weeks. So I got to make sure my skills are sharp. I'm going to show up on day one just ready to go. All right, so here, scary decimals. So let's see, 32, does that work out to negative 40, I believe. Yeah, yes, you have the absolute value right, but I believe it's negative 40. Because if you have a plus 1.6, this whole part has to be negative to make it 0. But right idea. So minus 1.6 on both sides. And we've got 0.04x equals negative 1.6. So for this part here, you could use a calculator. Otherwise, I'll show you like the math that you used to do in like 7th grade-ish when you had to do these by hand. Okay, but you're dividing both sides by 0.04, and now you have x equals. So the trick with these is I'm going to put a 0 here. If you're doing this without a calculator, I would multiply the top and bottom by 100 over 100. Because what that does is on top, the minus 1.60, this is going to move the decimal place 2 to the right. Okay, and then on bottom, 0.04, the decimal is also going to go 2 to the right. And now this is going to say negative 160 over 4. Okay, so that's just a much easier thing to do if you're doing this without a calculator. Okay, and then in this case here, question 32, we would have x equals negative 40. Okay, but once again, you are allowed to use a calculator in most, situations, especially at high school. I would say almost all high schools let high school students use calculators. I would be shocked if there's many that don't let you. Unless it's an AP class, because part of your AP exams, you're not allowed to use a calculator. Wait, what did I just... I meant to say this. Negative 1.6 divided by 0.04. Whoops. I don't know what I just pressed. 0.4. Let's see. Yay, same answer. All right. But once again, I like to show this stuff because I'm a believer in, your foundation in math should be strong. You don't want to neglect math that you learned back in the day because you might say like, oh, well, it's algebra now and I don't have to know how to add and subtract and multiply and divide. But the mechanics behind like why all that stuff works, if you really get the concept, that's just going to make you better overall at math, which I truly believe will help your algebra, will help your geometry, will help your algebra 2 and so on. Okay, like you want to have a pretty nice number sense because it might come in handy. Oh, set me to two times speed. That's awesome. Yeah, sometimes people recommend doing that. Someone recommended that on one of my AP videos, one of my practice tests. They're like, oh, set the speed to 1.25 for fast but understandable calc. So, yeah. I've had people say like, oh, you teach too fast. So that's why, like, especially for live streams, I try to at times go like slower. So let's see, get rid of that minus 20 by adding, and we have 0.8x equals negative 19 plus 20 is 1. And now divide both sides by 0.8. And now we could use the same trick here. You could use the calculator, or you could say, all right, this is 1.0 over 0.8. Just move the decimal 1 each. Do times 10 times 10. And that's going to give you 10 over 8. Okay, and then divide the top and bottom by 2. And this will simplify to 5/4. Okay, so 33 should be 5/4. All right, moving on. This one seems... Oh, okay, now we graduate to x's on both sides. All right, I was like, wait a minute, this seems easier. Oh, by the way, I went and looked... Oh, wow. So by July 2024, they think I will double. Ryan Tube, I hope so. I'm really doing my best to... It's hard not to focus on numbers because I can't lie. Like, of course, I want the channel to eventually hit 50,000, 100,000, a million subscribers. But I have to be honest with myself, and I say, like, yeah, I'm just not at that level yet. Like, I didn't hit 50,000. I didn't hit 100,000 because I'm just not at that level yet. For 2023, I just think the quality of stuff that I need to put out there, like, it just needs to be there. And that's the key, is to just try to focus on not the numbers, but focus on, like, just putting out good videos that you all want to see. Like, really paying attention to what all of you are asking me to do. To me, that's the key to making it on YouTube. I mean, it's of course, it's hard not to look. It's like the same thing with the stock market. Like, if you invest money, like, you shouldn't look at your stocks all the time. You should barely look at it. And I'm trying to treat the numbers the same way, but I almost like have to look at the numbers just to see what videos are doing better than others, because that taught me, like, ooh, the longer videos, the practice test videos, people really liked. So in the last school year, the 2022-2023 school year, I like tripled down and just made a ton of practice test videos. And that's why I think my numbers spiked up so much, because it was like, oh, that's what everyone wants to see. So sure, I could make practice test videos. Even though they take a long time. But I enjoy making them, knowing that they're helping people get ready for their end of the year exams. Okay, so x is on both sides. It's usually better to move the smaller x over to the bigger one. So the 2x is smaller than 7x, as long as x is not negative. But I just mean, like, it has the smaller coefficient. So I would do minus 2x on both sides. And now 2x minus 2x is gone. 7x minus 2x is 5x. And this is equal to 10. So now divide both sides by 5. And you're going to have x equals 10 divided by 5 is 2. Okay. Awesome. So moving on. Let's see here. 9x equals 44 minus 2x. So 9x equals 44 minus 2x. So now I have a minus 2x I'm going to move over. So to get rid of minus 2x, I'm going to do plus 2x. Because remember, for these kinds of equations, you want to get the x's on one side. So minus 2x plus 2x cancels. And then 9x plus 2x is 11x. And this is equal to 44. So now just divide both sides by 11. And you're going to have x equals positive 4. Okay, so 35, x should be equal to 4. So let's see it. For this one, now I know what I said before, like, oh, I would maybe move this x over here to keep everything positive, but it's fine to do minus 6x like this on both sides. Like, that's fine. And remember, there's an invisible 1 on both sides. So this is gone. 1x minus 6x is minus 5x, and this is equal to 30. So now divide both sides by negative 5, and let's see here. X equals 30 divided by negative 5 is negative 6. So 36, x equals, whoops, let's make that neater. X equals negative 6. Cool. All right. Let's see. So this one, now we got mixed numbers. So for this one, we're going to do minus 1 1/2 x on both sides. And now this turns into a 5th grade question. Meaning, like, after this cancels, what you're really thinking about is, 2 1/4 minus 1 1/2. So for this one, if you want, there's a few ways you could do this. You could treat 2 1/4. That's 2 1/4 or 2.25. And 1 1/2 is 1.5 like this. So if I subtract these, well, this one here, 5 minus 0 is 5. And then I borrow. And then this is 0.75. So as a fraction, that's 3/4. So this would give me 3/4 x equals -8. So there's not like one way you have to do these questions. But I personally would turn this into a decimal. I mean, if you want to see it like the 5th grade way, back when you borrowed and all that stuff. So like 2 1/4 minus 1 1/2. The problem with this is that 1/4 is less than a half. So when you subtract, like things get weird. You'd have to borrow from the whole number. So remember, 1 is equal to 4 over 4. So 2 1/4, I could say is 1 plus 1 plus a fourth, which is the same thing as 1 plus 4 over 4 plus 1 over 4. So this I could say is the same thing as 1, and 4 over 4 plus 1 over 4 is 5/4. And then minus 1 and 2/4. So now, like 1 minus 1 is 0. But then 5 over 4 minus 2 over 4 is just 3 over 4. So I mean, you could say 0 and 3/4, but that just looks silly. Just say 3/4. Okay, so now I will erase this since it's been explained. But that's the idea. But like you see, like this is kind of complicated. That's why just turn it into a decimal. There's not like, once again, you don't have to do a math question like any specific one way. As long as you get to the right answer, that's what counts. So divide both sides now by 3/4. And we'll say here, x equals -8 times 4/3. And now this one does not simplify nicely. -8 times 4 is -32. Over 1 times 3 is 3. So x equals -32 over 3 is our answer to 37. All right. Moving on. You can see these are picking up a little bit. They're not so simple if you're doing it without a calculator. All right, so here, subtract 0.2x on both sides. And now 0.8x minus 0.2x is 0.6 times x, and this is equal to 24. So now, one thing we could do here, just practicing many methods, is multiply both sides by 10. And this notation, you could put the entire side in parentheses like this. If I multiply 0.6 times 10, that's going to give me 6. Okay, just remember, if I do 10 times 0.6, the decimal moves 1 over, and that's 6. So that's 6x equals 240, and now divide both sides by 6. So x equals 240 divided by 6 is going to give us 40. So x equals 40 for question 38. All right. Very nice. So at Umar, Imran, very nice. Okay. So let's see here. Oh, so same idea as before. I would rewrite this. 2 3/4. Just know if you have 3/4, you have 75 cents. So this is 2.75x plus 4 equals 3.00 times x. And I'm writing it like this so that when we subtract, so we subtract here, you can see this canceling, and we have 4 equals, and if you do 3 minus 2.75, just think $3 and then versus $2.75, that's off by a quarter. So that would just give you 0.25 times x. And now divide both sides by 0.25. But remember, 0.25 is the same thing as a fourth. So I could just divide both sides by a fourth because it's easier to do a whole number divided by a fraction than it is to do a whole number divided by this weird decimal here. Okay, so that's just one way of seeing it. If you prefer, like, hey, that looks funny, I could just rewrite this as 1/4 in this step so that everything matches. Okay, so yeah, just know 3 minus 2.75 is equal to 0.25, and that's equal to a fourth. So we're just making a change in representation. So now we have x equals 4 times, and we flip the bottom, 4 over 1, which is 16. So x equals 16. Okay, 39, x is equal to 16. So moving on here to question 40. All right, we are making progress little by little. All right, let me take a quick water break. I could do this without food or water, but it's like, what's the point? I don't want to suffer here. I don't think people want to see me suffer. I don't know. Okay, 5x equals 2x minus 81. So do minus 2x on both sides. And now 2x minus 2x is gone. 5x minus 2x is 3x. And this is equal to minus 81. Now divide both sides by 3. And x equals negative 81 divided by 3 is negative, and then 81 over 3 is 27. Okay, if you have to, calculator or on the side, you could just do this. 3 goes into 8 twice with a remainder of 2, and 3 goes into 21 7 times, and it goes in perfectly. Okay, but the negative is involved, so 40 is negative 27. Cool, so this one, minus 5x on both sides. Question 41, we're doing minus 5x to get the x's on one side. This is gone. 2x minus 5x is negative 3x equals 36. Now divide both sides by negative 3. And x equals 36 over negative 3 is negative 12. 41 is negative 12. Cool. All right, we're getting there. All right, let's see. I would say move the x to the right. You don't always have to... Oh, food, water. Yes, 100. Yeah, if I was on an island, I would just bring food, basic food, and 100 equations to solve. I like that. That's funny. All right. Subtract 0.5x on both sides. I know we're so used to having the x's on the left. And some people aren't, you know, ambi-xers, but it's really nice if you can move your x's to the right as well. So these cancel, and you've got minus 30 equals. This, in my head, I'm thinking is like 11 minus 5 is 6, except with a decimal, so 0.6. Or just calculator. Divide both sides by 0.6. Remember, at any point here, we could just use a calculator and say, like, let's say, all right, negative 30 divided by 0.6. Like, we don't have to keep suffering here and just say, oh, negative 50. So that's why for 42, you know, x is equal to negative 50. All right, so yeah, you don't have to suffer through all of these. You can use a calculator to do the division, but, you know, if I had to do that myself, negative 30, 0.6 is the same thing as 6 over 10, which divide top and bottom by 2 is 3/5. So this is the same thing as this, which is the same thing as this, and 30 over 3 is 10. Negative 10 times 5 is negative 50. All right, so you can do it by hand, but once again, you have a calculator, you can use it. All right, so 43, 4 1/4 x equals, 9 3/4. I don't know if anyone is watches or has read Harry Potter, but you can't not mention Harry Potter, right, when you hear 9 3/4. I just imagine people like running into a wall when I hear this. Hopefully we don't hit a wall in this question. Okay, so this one, I would say here, yeah, maybe decimal again. So 4.25x, because 1/4 is 0.25, equals 9.75x plus 44. With decimals, I mean, whatever, I'll just do it this way. Do this. I'd rather deal with positive, like, you know, a positive and then minus like this when we're dealing with decimals. So when I remove everything from the left, there's nothing, there's 0 on the left. And now 5 minus 5 is 0, 7 minus 2 is 5, and 9 minus 4 is 5. Okay, the x tags along, plus 44. All right, so we're combining the like terms here. So subtract. So first we changed it to decimal form, then we subtract. And now I would subtract 44 on both sides. Okay, and I didn't give myself a ton of space here, so let me write this over here. We'll change colors even. So we have negative 44 equals 5.5 times x. So now divide both sides by 5.5. All right, and now x equals, and we're just going to use a calculator to close this out. So let's see. So negative 44 divided by 5.5 is negative 8. Okay, so negative 8. So 43 is x equals negative 8. Now, I can't help but show this. If you want to do this by hand, I just think 5.5 is the same thing as like 55 over 10. Which if you divide by 5 on top and bottom, that's 11 over 2. Okay, so this is 11 over 2. So if I had to do this by hand, I'll just draw that over here. Like if I'm doing negative 44 over 5.5, that's the same thing as dividing by 11 over 2. So this is negative 44 times 2 over 11. And then 44 over 11 is 4. And negative 4 times 2 is negative 8. Okay, so that's how you're doing that without a calculator. But realistically, I would tell my students to use a calculator. Like, you don't get style points when you take a test. That's just more for yourself. Okay, so now 2 things on each side. So move the x's together. Oh, I'm glad. So Umar, thank you for sticking around. Oh wow, you're in law school. Awesome work. Congratulations. That's a massive accomplishment. Yeah, because I know you got to take the LSATs and do like considerably well on the LSAT. So very nice. I'm glad you stuck around to do some math with us, even though like your days of algebra are like, basically like you don't have to be doing this. So thank you for coming to do this. And yeah, have a good day. Thank you for coming by. All right, so here when we have like 2 terms on the left, 2 terms on the right, but we have x's on both sides. So once again, I always like to get the x's to one side, and I prefer to move them to the left. 7x minus 3x is 4x plus 10 equals 54. I like to move the x's to the side that will give me a positive x. I don't know why, it just makes me happy. So now this is a 2-step equation. So subtract 10 on both sides. And you've got 4x equals 44. And now divide both sides by 4 to get rid of the 4 in front of the x. And x is equal to 11. Okay, we'll make that a little darker. So x equals actually makes that. We could make that a little neater. Let's try that again. Let's just rewrite it all together. All right, x equals 11. Yeah, I want it to look nice. I don't want it to, look sloppy. So x equals 11. All right, so this is what I was saying before. If you only like to move your x's left, you have to be kind of like, ambidextrous here. You got to be an ambixer. Move this over to this side because 5 minus 4 is 1. If you do 4 minus 5, you get negative 1. I don't know. I just prefer to do it this way. And now I'm only left with 20 on the left after 4x minus 4x cancels. And now 5x minus 4x is 1x, or just x, and then plus 9. So I'll make that 9 a little nicer. Okay, now minus 9 on both sides, we'll get x by itself. And 20 minus 9 is 11, and that is equal to x. Okay, if you want to say it this way, x equals 11, you can. That's like more traditional to put the variable on the left. All right, so moving on here, similar situation. This time we're going to do minus 6x on both sides. Okay, and I'm just making sure we're good here. So yeah, 11 was in fact correct. 6x minus 6x is gone. 7x minus 6x is 1x plus 9 equals, there's only 1 left. So now minus 9 on both sides. And 9 minus 9 is gone. X equals 1 minus 9 is negative 8. So x equals negative 8 is our solution to question 46. Question 47. X is on both sides. Why not deal with a negative here? So I'll do minus... Oh, wait a minute. This is... Let's see here. Is this the... Oh, okay. This is a wacky looking one already. Yeah. All right. Let's see. I'm trying to think of something here. Okay, yeah, minus 8x on both sides. I still like to get the x's to one side. So x minus 8x is minus 7x plus 4 equals, now 0 plus 4 is just 4. But watch what happens now. We do minus 4 on both sides, and 4 minus 4 cancels. We got negative 7x equals, 4 minus 4 also cancels to make 0. So you divide both sides by negative 7, and you're going to get x equals 0 divided by negative 7 is 0. So, of course, I had to include a question where 0 is the answer. And anytime I get 0 as an answer, I'm like, wait a minute. Something is strange. Like, you notice, like, I paused a little bit. I was like, is this really happening right now? Because if I check x equals 0 is a solution, 0 plus 4 is equal to 8 times 0 plus 4. These terms, like, just wipe out. And then 4 equals 4. Okay? Is in fact true. So, yeah, that's our answer here. There's another wacky situation that we're going to look at eventually, but just stay tuned for that. Okay, because I wanted this video to cover as many possibilities, as there are. Like, even though I made 100 questions here, it's not going to cover everything, but it's going to cover a lot. So that's another thing too. I want people to be as comfortable as possible with solving linear equations. So by seeing like almost every combination that could show up, should make you pretty good if you work through these and understand the solutions. So minus 5x on both sides. 2x minus 5x is minus 3x. And that's equal to just 36. Divide both sides by negative 3. And now x equals 36 divided by negative 3 is negative 12. And that is, let me draw that a little nicer. That is our solution to 48. We have x equals negative 12. All right. 49. Here we are. So let's see. Yeah, you know what? Let me move it to the right this time, just so we could practice being flexible. So minus x on both sides. 20 equals 12x minus invisible 1 is 11. So we have 11x minus 24. So simplify is nice. Now plus 24 on both sides. And minus 24 plus 24 cancels. 44 equals 11x. So divide both sides by 11. And now we've got x equals 44 over 11 is 4. Cool. So 49 should be x equals 4. Question 50. All right. So here, let's move this one over. To get rid of that minus 4x, we're going to do plus 4x. And remember, the theme when you have x's on both sides is you want the x's on one side. Okay, that is the theme for this set of questions that we're at so far. So x plus 4x is 5x, and then we have plus 20 equals 55, and now minus 20 on both sides. 5x equals 5 minus 0 is 5. 5 minus 2 is 3. So we get 5x equals 35. Divide by 5. And x equals 35 over 5 is 7. All right. Another theme here. What other skills do you need? For linear equations, you want to be good at your times tables. All right. It really helps to have that math down. I mean, yeah, like you could always type in. You could do all this math in the calculator, but it just makes you flow faster. So we made it to the halfway point. Okay. So now we are downhill. We are going downhill. Question 51. All right. But the questions are getting tougher and taking longer. But it's going to kind of like go up and down. Some of them are fast. Some of them are going to take forever. So still x's on both sides, but now a bunch of negative stuff. So plus 3x. Plus 3x. This is gone. 2x plus 3x is 5x. Plus 36 equals negative 54. And now go minus 36 on both sides. And you've got 5x equals. So in my head, once again, when we have minus like this, like a negative and then minus 36, when I'm doing this, what I'm saying is negative, and then I'm doing 54 plus 36. And I know 50 plus 30 is 80, and 4 plus 6 is 10, so 80 plus 10 is 90. So mental math. And now divide both sides by 5. And x equals Negative 90 divided by 5 is negative 18. So negative 18 is our solution. To 51. All right. So we will keep rolling here. 52. 5x minus 5 equals 9x plus 29. So this one, why not go this way? We'll go minus 5x. This is gone. And now minus 5 equals 9x minus 5x is 4x plus 29. And now we'll go minus 29 on both sides. So similar situation to before. I'm doing in my head 29 plus 5, but it's negative. So that's 34. So it'll be minus 34 equals 4x. And now this is going to be a strange looking answer, but it is our answer. So here, x equals negative 34 over 4. I would just divide the top and bottom by 2. Okay, so negative 34 over 4. In my head, I'm just dividing top and bottom by 2, and that's negative 17 over 2. All right, which you could write that as negative 8.5 even, if you want to write it as a decimal. I would just rather write it as a fraction. Okay, question 53. Now we start the distributive property. So distributive property, and I'm going to show 2 ways of doing this. And then I'll stop doing that as much because we have a lot of questions still to go. All right, so how far? Oh, we're an hour in. All right, so we're making nice progress here. So if we use the distributive property, we're doing 3 times x plus 3 times 2. Okay, so the long way is this is 3 times x plus 3 times 2 is equal to 18. All right, so that is the distributive property. You need to be awesome at this property when you're doing algebra, okay? Like there's no way around it. You have to be awesome at the distributive property. So this becomes 3x, let's make that a smidge neater. 3x plus 3 times 2 is 6 equals 18. And now it looks like what we were doing before. So minus 6 on both sides. 3x equals 12. And now divide both sides by 3. And you'll have x equals 12 divided by 3 is 4. Okay, so question 53 works out to x equals 4. Now, the second way of doing this, but I wanted to teach the distributive property. This is 3 times x plus 2. So I could just divide both sides by 3. And now this cancels. And now there's a 1 in front of the parentheses, so the parentheses could just go away. 18 divided by 3 is 6. This is way cooler. At least I think. All right, same answer. But this, once again, you should know the distributive property. Sometimes the distributive property is like kind of unavoidable. So the way in purple works, but distributive property is nice. So here, let's distribute. Negative 2x, when we do negative 2 times x, and then negative 2 times positive 4 is negative 8 equals 18. And now plus 8 on both sides. So we have negative 2x equals 26 when we do 18 plus 8. Divide both sides by negative 2. And now a positive divided by a negative is negative, and 26 over 2 is 13. So 54 should be negative 13. All right. Moving on here. So this one, once again, we can distribute, or we could use that nice shortcut. 5 times x minus 3, just divide both sides by 5. X minus 3 equals 20 divided by 5 is 4. Do plus 3 on both sides. And now you've got x equals 4 plus 3 is 7. So 55 should be x equals 7. All right, so here we'll distribute, and this is one of the most common mistakes. So one thing, just I'll say watch out. Let me write it over here. Watch out for sign changes. Okay, the most common mistake with these types of equations is missing the sign change. All right, so just that is one thing you got to be really careful of. So here, negative 7 times x, negative 7 times negative 2. We're going to do negative 7x. And now negative 7 times negative 2 is positive 14. And this is equal to 21. So now minus 14 on both sides. And you got minus 7x equals 7. Divide both sides by -7. And x equals 7 divided by -7 is -1. Okay, but once again, the sign change is what people will miss. They'll write -7x minus 14, and that will throw the entire question off. All right. Oh, Ryan Tube, thank you so much, yeah, for following along and helping out here. But yes, I agree. Same answer. So more distributing. But now it's the x is not leading in the parentheses. So slightly different look. 3 times 2 is 6. 3 times minus x is minus 3x. And this is equal to 20. So now subtract 6 on both sides. So this is our two-step equation. Needs to just be automatic. So that was like sort of like the beginning portion of the video was the two-step equation. But now once you know distributive property, your two-step equation is just always ready to go. You just have to be amazing at it. Then you got minus 3x equals 20 minus 6 is 14. And now divide both sides by -3. All right, this is not a nice looking answer, but it is our answer. Now, one thing I want to point out here is you could write your answer 3 ways. You could write 14 over -3. You could write -14 over 3. Or you could write negative and then 14 over 3 like this. All right, I'll probably write it the last way. I usually write it like this way or this way. This looks kind of strange. I don't know why. I'm not a big fan of that one. So minus 14 over 3 is our solution. All right. 58. So here we go. Let's do this. Distribute the -8. -8 times 3 is minus 24. -8 times minus x is going to change to plus 8x. And this is equal to 32. So now go plus 24 on both sides. This will cancel. 8x equals 2 plus 4 is 6. 3 plus 2 is 5. So we got 56. And now divide both sides by 8. And this will divide evenly. We know that 8 times 7 is 56. So 56 divided by 8 is 7. X is equal to 7 is our solution to 58. Cool. All right. This one, you know what? I'm going to use that other method here. I could distribute. What should I do? Distribute or divide? I mean, dividing by -3 is just easier. Divide both sides by -3. And now you just have 5 minus 2x equals 12 divided by -3 is -4. And then we could subtract 5 on both sides. 5 minus 5 is gone. -2x equals -4 minus 5 will give you -9. And now divide both sides by -2. And this will give you x equals -9 over -2 is positive 9 over 2, or 4.5. Either one, but I like to write it as a fraction. All right, if you wanted to use the distributive property, you're like, wait, how do you do it by distribution? Then you go like this. You're going to have -15. -3 times -2x is plus 6x equals 12. And now you go plus 15 on both sides. And you'll have 6x equals 27 after you add those two, and then divide both sides by 6. And then x equals, divide the top and bottom by 3. And you still get 9 over 2. All right, same answer. So either way will work. All right, so now we have not just distributive property, but there's like stuff attached to the parenthesis. Now, just know when there's a 1 in front, or yeah, like just a invisible, there's nothing in front, there's an invisible 1 in front. So in this situation, the parentheses could just drop. All right, this is a situation here where we could just say, and let me change up the colors here. Maybe we'll go with here, this dark green. So we have x plus x minus 7 is equal to 19. Because there's technically, once again, there's like a 1 in front. And if I distribute a 1, I have 1 times x is x. 1 times minus 7 is minus 7. So the parentheses, see you later. And now combine like terms. X plus x is 2x. Minus 7 equals 19. And now plus 7 on both sides. So we've got 2x equals 26. Divide both sides by 2. And this will give you x equals 13. Okay, so 60 should be x equals 13. All right. Oh, the papers are getting lighter. I'm just making sure our answers are all good so far. 61. All right, so this one is a common mistake. All right, I'm going to write this. Don't. All right, don't ever do this. Don't say x minus 12 minus x. Most common mistake is people go to subtract and they forget to distribute. All right, that's what you're not going to do. Think of that as a minus 1 in front. And when you send the minus 1 through, this is going to be x, and you have minus 1 times 12 is minus 12. Minus 1 times minus x is plus x. And this is equal to 38. So now combine like terms, you have an x and an x. X plus x is 2x, and then minus 12. Okay, so once again, just emphasizing here, we have an x plus x, and that becomes 2x. The minus 12 just tags along for the ride. Equals 38. And now just add 12 to both sides. And it's our two-step equation. 2x equals 50. Divide both sides by 2. And now x equals 25. All right, so 61. X is equal to 25. 62. So now we have parentheses to the first power. When you have a situation like that, you could just get rid of the parentheses. So sometimes they put parentheses there, and it's a question that's like so easy it's difficult. Like the parentheses are just a distraction, but they really don't add anything. You know, like if they had just written the question like this is like the same exact question. So now one thing that, you know, might be a struggle here to be on the lookout for is this part, like the minus 3x plus 7x. So when you're combining these two, just think of this as you're doing negative 3 plus 7 is positive 4. Okay, so these make 4x. You are allowed to use the commutative property of addition. You could even say this, like 14 plus 7x minus 3x equals 94. Like this is allowed. Like if this, let me just make that neater. If this makes it easier for you, then think of the question like this. Okay, but in either case, you're going to get 14 plus, let's fix that. 4 was the 7x minus 3x is 4x. So you have 4x equals 94. So once again, just really emphasizing here, this is going to simplify to 4x. So now we could do the minus 14. And we've got 4x equals 4 minus 4 is 0. 9 minus 1 is 8. 4x equals 80. Divide both sides by 4. And now x equals 20. Okay, so 62, x is equal to 20. All right, let's just see here. All right, moving on. Question 63. So now I would distribute this minus 2. So we've got 25 minus 2 times x is minus 2x. And now we got minus 2 times minus 5 is plus 10. All right, once again, be careful of those sign changes. And now you got a 25 and a positive 10. Those can combine to make 35. Now you could write this two ways. You could say, like just thinking about this out loud, you could make this on the left side say 35 minus 2x, or you could write the negative 2x, and you could write the constant positive 35 to the right. Either one of these is fine. Whatever makes you happier is what you could write. I feel like it's more natural to write it the first way. Like people just say, oh, 25 plus 10. The 25 is over here, and that's going to become 35. But either way, whatever you prefer, it's equally correct. Okay, so these 25 and 10 made 35. And now go minus 35 on both sides. So here, what I'm thinking about next is I'm doing 35 minus 19 in my head. So this, I would have to turn to 15 minus 9 is 6. And then 2 minus 1 is 1. So this would give me 16, but since it's flipped, it's going to make negative 16 equals negative 2x. And now just divide both sides by negative 2. Because remember, the negative 2x just carries down. So we divide by that coefficient in front of the x. And we have x equals negative 16 over negative 2 is positive 8. So 63, x is equal to 8. All right. So moving on here. Once again, anybody who just joined, thank you so much for joining this live stream. Or if you're watching the video, remember there is a link in the description below that will lead you to a PDF of all the questions I'm doing. So if you want to try these out, by all means do that. I would recommend that you practice these questions. All right, so -8 on both sides. Now, look, we could distribute first, but math is not always so rigid. You don't have to do that's what gets students nervous sometimes. Like, oh, I have to do this one specific way. There's a lot of right ways to do questions. So in this case, I'm just like, all right, let me get rid of that +8. Because if I do distribute, I guess this one I'll do both ways. But if I distribute, I have to make sure I don't do 5 times that 8 because that's not in the parentheses. All right, so now we have 5 times 3x minus 2 is equal to 43 minus 8 is going to give us 35. Okay, so that's going to give us 35 once we subtract. Now, even from here, I could distribute, or I could use that cool trick from before. I'm just going to divide both sides by 5. And I've got 3x minus 2 now on the left equals 7. And now two-step equation, do +2 on both sides. And we're going to have, let me just drag this up a little bit. So just so that we have some space. Okay, so now this is going to make, we're going to have 3x equals 9. And I'll write that over here. That's going to give us 3x equals 9. So divide both sides by 3. And x is equal to 3 for question 64. So what I was saying a moment ago, this is also fine if you just get rid of that stray mark. If you look at this equation, how we started it here, solved it in a maybe not the most obvious way, but 5 times 3x is 15x. 5 times -2 is -10, and then +8 equals 43. We could also go this route here, but then you'd have to do, -10 plus 8 is -2, and this is equal to 43. So then you do +2 on both sides, and I guess I'll just write the rest over here. So that's 15x equals 45, same exact answer. Okay, x is equal to 3. So either way, if you do it the red way or the green way, you get the same answer. All right, so now double distributive property. Look out. So here, we're distributing the 3 to this part. So we have 3x, and then 3 times -5 is -15. But then I also have to distribute the -2 to this part. So I have -4x when I do -2 times 2x, and then -2 times 1 is -2. And this is all equal to 0. Okay, so now combine like terms. 3x minus 4x, that's going to make, I think 3 minus 4 is -1, so I have -1x. I don't have to write the -1 there, but just know it's there, -1x. And then this part, -15 minus 2, I'm going to do, think of it as, I keep bringing this up, but just to reinforce this idea, -15 minus 2 is the same thing as -15 plus 2. So that's -17 is equal to 0. Okay, and then just add 17 to both sides. And you've got -x equals 17. And now divide both sides by -1. And then we have x equals 17 over -1 is -17. So 65 should be -17. All right, cool. So moving on here. Question 66. All right. So, decimals. There's a way to avoid decimals altogether. I think this is worth showing. Oh, you know what? I'll solve this the painful way, and then I'll show, another way to do this as well. So if we just start this, distribute, but 2 times 0.4 is 0.08. So I have 0.08x plus, and I do 0.04 times 1 is 0.04. And now here I'm distributing the -0.03. So if I do times 2, that's going to give me 0.06, and I just tack on the x. And then if I do minus times minus is plus. And I have 0.03 times 5 is 0.15. Okay, so you could do that in a calculator, but I just think 3 times 5 is 15. But, you know, with the decimal, it's going to be 0.15 because we're multiplying by 0.03. If it was just 0.3 times 5, that would be 1.5. So 0.03 times 5, that's why it's 0.15. Okay, so the decimal just moves a little bit more. All right, but calculators otherwise. You don't have to suffer here. You could do this in a calculator. So you could just solve this in terms of decimals here. But I'll show you a trick after if you'd rather do it a different way. So now this, we have 0.08x minus 0.06 times x. So these two are going to combine to make 0. Just think 8 minus 6 is 2, so it's going to be 0.02x. And then for this part, we have 0.04 plus 0.15. That's like 15 plus 4 is 19. So we have 0.19 equals 0.29. And now do minus the decimal 0.19 on both sides. So this is gone, and now you have 0.02x equals, and this is going to make 9 minus 9 is 0, 2 minus 1 is 1, and we get this. So now just divide by 0.02. And this is x equals, and remember, this is like doing 10 divided by 2. If I just move the decimal 2 to the right, I get 10, and if I move this one 2 to the right, I get 2. And 10 divided by 2 is 5, so this will give you x equals 5 for question 66. Okay, now the other way of doing this would be, so I'll just maybe just get this one set up here. That was, oh wait, wow, that actually kind of fixed itself. Is that, I don't know if that's looking nice. Let's try that one more time. All right, that's, whatever. That's, I guess, good enough. Sorry if it's crooked. That bothers you. Actually, I don't know if we're going to have space. Let me see. Do we have space to... So, all right, the other way of doing this, maybe I'll just screenshot this. So let me erase this part. And take a screenshot. Just show you the, the setup. Here is what you could do is you could multiply everything by 100. Okay, so we can multiply everything by 100. Now, the reason why I'm doing this is if I do 100 times 0.04, that's just 4. So I'd have 4 times 2x plus 1 minus, so that's this times this. Then I'll have 100 times minus 0.03 is going to give us minus 3 times 2x minus 5. And this equals 100 times 0.29. The decimal moves 2 to the right to become 29. So you would get this resulting equation. And if you solve this one, let's just see. I'll do this fast. So distribute, we get 8x plus 4, and we get minus 6x plus 15 equals 29. And then this would give us 8x minus 6x is 2x. 4 plus 15 is 19 equals 29. And if you do minus 19 on both sides, I'll put this over here, that's going to give you 2x equals 10. 29 minus 19 is 10. And we divide both sides by 2, we also get x equals 5. Okay, so however many decimal places you have, if you multiply by like a 1 with that many zeros, it will get rid of all the decimals. Okay, so some people would prefer to do that because if you look, see this equation here, there's no more decimals. Okay, so that's an option. But whatever, doing it this way isn't terrible if you have a calculator. Fractions. All right. Same thing with this one. The option, I look at the least common denominator is 12. So I could multiply everything by 12. And that'll get rid of all the fractions. Or we could just deal with the fractions. So we distribute here. And if we just go forward with this. Oh, your region scores would be out today. So RyanTube, yeah, I hope you find out. I hope you get it by the time we're in this live stream here, because that would be cool to find out how you did right here on the live stream. But hang in there. I know you're looking forward to it. So just hang in there. So here, I'll do this part in my head. Whoops, let's make that a little nicer. That's better. So 3/4 times 8 I'm doing 8 divided by 4 is 2, and 3 times 2 is 6. So that becomes 6 plus, if I do 3/4 of 4, just think 4 over 4 cancels, and this becomes 3. So that's going to give us 3x. And now minus, I distribute a minus third, so I have minus 1/3. I can just write it without the minus. 1/3 times 6 is like doing 6 divided by 3 is 2. So this becomes minus 2x, and then minus 1/3 times 3. So I'll just write that over here. 1/3 times 3 simplifies to 1. So if I have negative 1/3 times positive 3, that would make minus 1. And this equals 9. So now I combine like terms. 3x minus 2x is x. And then in one step, I could do 6 minus 1 is 5. So I have x plus 5 equals 9. And now do minus 5 on both sides. And you're going to have x equals 4. Okay, so that's here. Now, the other way of doing this, so now I will remove this, because I did mention the least common denominator, and I didn't use it, but I just want this to be there for people in case they prefer not to deal with fractions. So the other option, which I don't know if it's easier or not, it might or might not be. It's your opinion, I guess, if you think so. That least common denominator of 12, we multiply this fraction by 12, this one by 12, and we also have to multiply this by 12. So, if we do it this way, now we're doing, so we should get x equals 4 as our answer. We're doing 12 times 3/4, and now 12 over 4 is 3. 3 times 3 is 9. So this becomes 9 times 8 plus 4x. And now I'm doing 12 times 1/3. And 12 divided by 3 is 4. So that would be minus 4 times 6x plus 3 equals 12 times 9 is 108. Okay, so the numbers are a little bit bigger here, but I don't know if you think this is easier. 9 times 8 is 72, plus 9 times 4 is 36, so we have 36x. And now we're gonna get a double minus here. So minus 4 times 6 is minus 24, so we get, make that neater, minus 24x. And then minus 4 times 3 is minus 12 equals 108. So we combine like terms. This is going to make 12x. And 72 minus 12 is going to make 60. And this is equal to 108. And now subtract 60 on both sides. And this is going to give you 48 equals 12x. And same answer. We divide both sides by 12. And you're going to get x equals 4. Okay, so two different ways of doing this, but some people like to take the least common denominator and multiply all throughout by the least common denominator to get rid of it. Because what did we accomplish by doing this? Now the fractions are gone, and we just have nice integers. Okay? Oh, yeah, thank you, Ryan, too. Yeah, I definitely want to know how you did and stuff, because I know you're really focused on getting that 100. So awesome stuff. And then you could get that sushi, like you said. All right. So now we're distributing the 4. So we have negative 18 equals negative 6x. 4 times 2x is 8x. And then 4 times 3 is 12. So here we can combine these two. Negative 6x plus 8x. You're doing negative 6 plus 8 is 2. And then just tack on the x. Plus 12, and now minus 12 on both sides. So we've got negative 18 minus 12 is minus 30 equals 2x. To get rid of the times 2, just divide both sides by 2. And x equals negative 15. All right. 68 is done. And now we move on. Question 69. So this one we distribute. 2x plus 2 equals 2x plus 5. And you say, all right, let me get the x's together. Minus 2x on both sides. And you get, 2 equals 5. This is a false statement. Okay, this is false. So what does that tell us? There are no solutions. Okay, so no solution. Okay, no solution here. I know when that happens, it's like, wait a minute, that seems like if we explore this a little bit more, 2x plus 2 equals 2x plus 5. if you were to graph both of these, so just think like system of equations. 2x plus 2, let me draw that a little neater. And yeah, that's good enough. So let me make this a different color. So this could be, let's say, the line 2x plus 2. And this could be the line 2x plus 5. They don't intersect. Okay, these lines here, if I use the notation, are parallel. They have the same slope. So they will never intersect. And they have different y-intercepts. So because of that, these lines have no common solution between them. They have no solution. So this is just something to look out for. Anytime you get matching slopes, like remember this idea like y equals mx plus b. I know this is like kind of out of the scope of the video by talking about slope and y-intercept, but this is the slope of your line. And this is your y-intercept. So you see out here, these two equations, like the slope too is the same, but they have a different y-intercept. There will not be a solution to this equation. All right, so I had to throw one in like this. And then that segues perfectly to this situation. All right, I wanted this video to be as comprehensive as possible. So this is also a possibility. We distribute here, and we get, 3x plus 6 is equal to 3x plus 6. If the left side and the right side match completely, then x could be anything. Okay, because if you start to solve here, like this is gone, and now you got 3x equals 3x, you could say here, like, all right, minus 3x on both sides. And now at this step, you're going to have 0 equals 0. And this is always true. All right, 0 is always equal to 0. So that means infinite solutions here. A nice way to say this is you could say x is any real number. Okay, this is one way of writing it. Like you could just write it like this. All right, or a nice way to say it, I like to write this. X is an element of the real numbers. All right, this is a cool way of saying it. All right, just know, like this symbol here, like this means like is an element of. All right, this is just nice notation. And this is the symbol for, like the real numbers. Okay, is the like the double slash, like the double vertical line with the R is real numbers. All right, so this is like the cool way of writing it. Like, oh, x is just an element of the real numbers. X could be any real number, and it'll work. And you could try it out. Like pick like 5 different numbers for x, plug it in. It's always going to be true, this equation. All right, so I'm glad I got those out of the way because those are like the slightly annoying ones. But now more distributing here. Okay, double distribution. 71. Yeah, let me just make sure we just finished 70. So question 71. So now we'll go back to green, or actually let's go to pink, whatever. So 2 times, can we do this a strange way? Or I guess we just do double distribution here. That's an option. If you want to get a little creative here, now that we're on question 71. Oh, Ad Fayaz, thank you for saying hello. Hello to you and great work. I appreciate that. I'm doing my best here to, I'm trying something different here. But I'm glad I got 74 people to stop by in the time that this stream has been going. But this will be on YouTube after. So thank you for swinging by. And, feel free to download this PDF and follow along. So here, we could just do double distribution. If we want to get really crafty here, we could even divide both sides by 2. And now 2 over 2 cancels, and you get x minus 1 equals 4 divided by 2 is 2. So you get 2 times x minus 6. So this is allowed. This is fine. Divide both sides by 2. I'm sorry. Distribute the 2. We already divided both sides by 2. So now we distribute the 2. We have 2 times x, and we have 2 times minus 6 is minus 12. And we get an x minus 1 here. So in this case, I would go minus x on both sides. And now you got minus 1 equals 2x minus x is 1x, or just x, minus 12. And now add your 12 to both sides. And 12 minus 1, or negative 1 plus 12 is 11, equals x. So question 71, x equals 11. Cool. So this one I'll do by distributing on both sides. So distribute the 3. We have 3 times 2 is 6. 3 times minus x is minus 3x. Equals 2 times 4 is 8. And 2 times minus 3x is minus 6x. So this one, I would go plus 6x on both sides. So minus 6x plus 6x is going to cancel because they're matching opposites. And then we have 6 plus, because we're going to have a negative 3x plus a 6x. Think of 6 minus 3 is 3, so we're going to have a 3x left over here. Equals 8. And now go minus 6 on both sides. So you see, it always comes back to that two-step equation. So that's why in the beginning of the video, I did two-step equations to make sure that part is like perfect. Okay, so you got to think about which part are you struggling the most with, and that's what you want to really make sure you're strong. All right, so 3 over 3, divide both sides by 3, and you're going to have x equals 2/3. So 72, x is equal to 2/3. All right, we are getting there. We are making nice progress. Oh, we're an hour and 40 into this. All right, just keeping track of time. We're just about an hour 40. Okay, so now distribute the minus 3. And you're going to have minus 3 times 4 is minus 12. Minus 3 times minus 2x is going to become a positive. 3 times 2 is 6, so we get positive 6x. Equals negative 7 times 2 is negative 14. And then negative 7 times negative x is positive 7x. And then from here, in this case, I would actually want to move the 6x over. I think this will keep the numbers nicer. So this is gone. And now we have negative 12 equals negative 14. So make sure you bring the signs with them. 7x minus 6x is 1x, so I just have plus x. And now plus 14 on both sides. So this is gone. And then 14 minus 12 is 2. So 2 is equal to x. But I'll write it this way. I'll say x is equal to 2. Cool. All right. 73 is done. All right, now proportions, which turn into linear equations. That's why I included them. So these, there's a few ways to do them. When it's x over 4 equals 7 over 8, you could cross multiply. Or if the x is on top, you could just multiply by the denominator 4. Okay, because 4 over 4 cancels. And then x equals, if you do like this cross canceling here, what I'm imagining in my head is 4 over 8. If I do 8 divided by 4 is 2, it's like essentially like I'm dividing the top and bottom by 4 and getting 1/2. Okay, so 4 over 8 reduces to 1/2. So this becomes 7 over 2. Okay, if you want to write your answer also as 3.5, either one of those is perfect. Let's write an answer out as a decimal. Sure, 3.5. Okay, is our answer here. But now let's say you get a situation where the x is on bottom. So I'm going to show 2 ways of handling this. Because once again, I want you to leave this video with as many algebra skills as you can for solving linear equations like this. If you cross multiply, you could say 5 times 2 is 10. 6 times 5x is 30x. So I'm going to write the x on the left. 6 times 5x is 30x equals 5 times 2 is 10. Divide both sides by 30. And now you've got x equals, this will reduce the common zeros, cross off, to 1/3. Okay, so 75 is 1/3. I'm going to show another way of doing this though. 6 over 5 equals 2 over 5x. But just remember, this rule I'm about to show, or this technique, this only works. So this method will only work. I'm sorry, let me just write it all out. So this method will only work. When, let me write it over here, when we have 1 fraction equals like 1 fraction. Okay, this will not work. And what the method is you're allowed to flip both sides. Okay, so if I flip both sides, I'm gonna have 5 over 6 equals 5x over 2. So if you just think about that carefully, like why did that work? You would agree with this statement, right? 1/2 is equal to 4/8. That's true. If I flip both sides, I get 2 over 1 equals 8 over 4. And yes, 2 divided by 1 is 2. 8 divided by 4 is also 2. So this method works when it's 1 fraction equals another. But don't say I taught you this. Like, oh, 1/3 plus 2/3 equals 1 or 1 over 1. I could do this when it's like the sum of two fractions equals one fraction. Like, no, don't, like, not here. Like, so I'm going to say, no, not here. Because you would say 3 over 1 plus 3 over 2 equals, flip that as 1 over 1. Is 3 plus 1.5 equal to 1? Like, no, that would be 4.5 equals 1, which is, like, not true. So not here, but here is fine. And now you have the option of just multiplying by 2 over 5. So 2 over 5, and now 5 over 5 cancel. Oh, let me cancel this side too. 5 over 5, 2 over 2 is gone. So you have x equals 2 over 6, and 2 over 6, if you divide top and bottom by 2 to reduce, you're also getting 1/3. Okay? So nice little trick to have up your sleeve. All right, question 76. So we are on the final quarter. All right, we made it to the fourth quarter. So let's get to this. We could do this now. Well, yeah, once I hit this point, I'm feeling good. In the beginning, it's like, oh no, I'm tired. Like, I got so much more to go. But like now, it's like, all right, we could get there. So we're going to do 2 times x minus 1. So cross multiplying. Just know the rule for this, if you want to write it formally, when you have this, allows you to say like a times d equals b times z. All right, provided, of course, that like b is not 0 and d is not 0. Like that this is like a approved method. All right, this works. So I'm doing 2 times x minus 1 equals 3 times 8 or 8 times 3, which is 24. And now I could distribute, or if I want to be fancy, I could divide both sides by 2. And now I have x minus 1 equals 24 over 2 is 12. And then go plus 1. So x equals 13. So 76 should be 13. Okay. All right, moving on. 77. So 77, let's see. Another proportion. So more cross multiplying. So I'm going to do 4 times x plus 2 first. Equals negative 10 times 3 is negative 30. And this won't divide nice. So this one I'll go ahead and distribute. That's 4x plus 8. Yeah, because I'm just thinking, if I divide both sides by 4, I mean, I guess technically I could. 30 divided by 4 is 7.5. And then we would be subtracting 2. So we'd have negative 7.5 minus 2 is negative 9.5. We would get, same answer. But I would rather do it this way. So we'll just do it a different way. So now minus 8 on both sides. So let's see if we get negative 9.5. Like it should be the answer. All right, equals negative 38. We're doing negative 30 minus 8. And now divide by 4. And x equals, if you divide the top and bottom by 2 to reduce, you're going to get negative 19 over 2. Okay, and yes, negative 19 over 2 is the same thing as negative 9.5. So either way, it checks out. Cool. 78. So now a proportion where there's x's on top and bottom. So that's going to give us 3 times x plus 1 equals 5 times x. And now here I would distribute 3x plus 3 equals 5x. And now go minus 3x on both sides. Okay. So now I'm going through this part faster because we already did x's on both sides. We did plenty of those examples. So like that's the whole point, is when you're building skills to do questions like this, if you're struggling with this part, then you got to go back to the easier questions until you master like the simpler skills. So, just be yourself. Thank you. You surely will be blessed. I appreciate that. I consider myself very lucky to see the channel have gotten this far. So I already do consider myself, blessed if you're going to say it in that sense. So just thank you for being a part of it. I appreciate your kind words, but just being here once again with all of you, it's I'll pause for a second to talk to the crowd. My classroom, the high school I work at is very satisfying for me. Like I really, 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 truly value the classroom. I'm going into my 11th year of teaching, and I still enjoy the classroom. Being on YouTube is like a way for me to expand the enjoyment I get out of being in a classroom. Like just knowing, like one of my biggest days on YouTube, I had 50 something thousand views, and they might not have been all unique viewers, but let's say even like 15,000 people came to watch me that day. Like, to me, that's like pretty remarkable. That, let's say, the most I could have is around like 150 students. So 15,000 is like times 100. That's like I'm in 100 high schools, like in addition to the one that I do work at. So that's why, like, just thank you for being a part of it, because like those 15,000 people, like, you're all like one person. So like I appreciate. Oh, and from India too. That's another part that's great, is knowing how far the videos go. I love that I could talk to people from India. 2023. That's one of the special things about this year. Is just how far the classroom has come. So thank you at Just Be Yourself, and hello from New York, or from the United States. So now let's see. 5x minus 3x is 2x. Divide both sides by 2. And you got x equals 3 over 2, or 1.5 if you want to turn it into a decimal. Either way is fine. All right. So that was 78. And now we move on to this one. So more distributing. 4 times x minus 10 equals 9 times x. So distributive property, 4x minus 40 equals 9x. Okay, we're doing 4 times x is 4x. 4 times negative 10 is negative 40. So now minus 4x on both sides. So this part here is gone. And we're going to have negative 40 equals 9 minus 4 is 5. So we have 5x. Divide both sides by 5. And now x equals negative 40 over 5 is negative 8. All right. So negative 8 is the answer to 79. More proportions. All right. It's going to switch in the last phase to literal equations. Okay. So that is the last type of question that I will be doing. All right. But we're in the final fifth. So now we have 8 times x plus 5 equals 6 times 5x minus 4. And from here, just distribute. Okay, so 8 times x is 8x plus 8 times 5 is 40. And this is equal to, we have 6 times 5x is 30x. 6 times minus 4 is minus 24. So I would move the 8x over to keep the x's positive, like the coefficient of x positive. So this is gone. And coefficient, remember, is the number in front. I'm not sure if I said coefficient at all yet, but I'm saying it now. So we have 40 equals 30x minus 8x is 22x. We have minus 24. So go plus 24 on both sides. Okay. So now we have 64 equals 22x. And now divide both sides by 22. And let's just see here. This number looks kind of funky. Let's see. Divide the top and bottom by 2, and you're going to get 32 over 11. All right. Now, just know, anytime I get a wacky answer like this, so of course, checking your work is a practice that when time permits, always check. So me getting a kind of silly answer like this, like 32 over 11, like I'm a little like, is that right? You could always check. You could do, alpha y equals enter. You got 8 on top over 5 times 32 over 11. So I'm claiming x is 32 over 11. And then we tack on the minus 4. So we get this. And I'm going to go to mode here and write this as a decimal. So let's go ahead and do that. I don't know, I just prefer decimals on calculators. Fraction form could be a little annoying. All right, so that's our decimal answer. But now the right side, I'm going to do alpha y equals enter again. And the right side is 6 over x plus 5. So 6 over 32 over 11. And then plus 5. And then if the decimals match, we're good. And they match. So this answer is good. All right, so once again, when you get a weird number, I wanted some of the answers to have weird numbers. Like, you should go back and check. All right, so here, that's an invisible 1 in front. So distribute the negative 1. So question 81, we're distributing that invisible negative 1. We're going to have 3x. And now negative 1 times x is minus 1x. Minus 1 times positive 1 is minus 1 equals 6x plus 1. And now combine like terms. That's 3x minus 1x is 2x minus 1 equals 6x and then plus 1. So from here, I would just go minus 2x on both sides. I like to, once again, have the x's with the positive coefficient. It's just a habit, I guess. So now we're left with negative 1 equals 6 minus 2 is 4, 4x plus 1. And now to solve for x, minus 1 on both sides. 1 minus 1 cancels. Negative 1 minus 1 is minus 2 equals 4x. Divide both sides by 4. And x equals negative half. Okay, so question 81 should be negative half. Oh, I look different from the thumbnail? That photo for the thumbnail was not, that was in the last year. I'll make sure that when I get really old, I'm not going to use, like, pretend I'm, like, super youthful. But, yeah, that's cool. I appreciate people who notice the things like that. It's tough coming up with thumbnails. That's, like, that's one of the behind the scenes of YouTube that's very tricky. Like, your thumbnails have to be good. Unless your content is, like, so... I know some YouTubers, like, some of my favorite YouTubers, their videos are, like, so good that, like, they could just put, like, I don't know, like, they could take a picture in, like, a dark room and make that their thumbnail, and, like, the video will still get, like, millions of views because their content just has been established so well. So, but, yeah, no, I hope I'm somewhat recognizable, but so different. Maybe it's my my evil twin. I don't know. No, I mean, that was definitely me in the picture. I promise. All right. So distribute the minus 3. Now we have x. Minus 3 times 1 is minus 3. Minus 3 times minus x is plus 3x. Equals 47 minus x. So combine like terms. Okay. And we'll go back to full screen here. So we have an x plus 3x. So those will combine to make 4x minus 3 equals 47 minus x. I will reach billions. Oh, thank you so much. I hope to one day, you know, just get this channel to go as big as possible. I really am trying here. I'm having fun though. All right, like it's a fine balance between like really trying to make the channel big, but like enjoying the process too. And I am enjoying the process. I honestly mean that. This like I'm having fun doing this. 4x plus 1x is 5x. Minus 3 equals 47. And now we're going to add 3 to both sides. So we have 5x equals 50. And we'll divide both sides by 5. So x is equal to 10. Yep, 82, x equals 10. Okay, 83. Moving on. We're making progress here. All right, so this is one of those, like, so easy it's difficult. There's an invisible 1 in front. This is to the power 1. So in this case, you could just drop the parentheses. Right? This really will sometimes make students freeze. But this is, like, not as bad as it looks. So now the left side stays 3x minus 8. The right side, I would combine like terms. 10 plus 4 is 14. We have minus 8x. So now go plus 8x on both sides. Oh, you just took 3 small sips of some mango juice and realized it was fermented. You'll probably be, but I'm not gonna give medical advice on YouTube. I'll just say I hope you'll be all right. But I would ask somebody at home. That's one of my things in the classroom too. If kids are like, oh, like this hurts or that hurts, like what do you think? I'm like, that's a great question for the nurse, because yeah, healthcare is like, yeah, I will stay in my lane. I'll just say, Ryan, too. I hope if you're feeling okay, great. But I'm gonna vote, you being okay here. But yeah, I would little Google search. That's I would just be like, oh hey Google, like what's the deal with when this happens? But yeah, medical advice, I stay in my lane. Because yeah, I studied math. I'm not like too medicine savvy and whatnot, but yeah, I think you're gonna be fine. All right, 11x minus 8 equals 14. So plus 8 on both sides. So now you got 11x equals 22. Divide by 11. Okay, x equals 2. So not bad. Just drop the parentheses and then move on from there. All right. Uh-oh, something wacky looking. So the left side is fine, so we'll just rewrite it. The left side is 2/3 x minus 11 equals, distribute the 4. 4 times 16 is 64. Minus 4x. And the minus 1/3 just tags along. Okay. Now, from this step, there's a few ways we could go with this. And let me see what's the easiest. I'm going to do something a little bit bold here. I probably could have done this in the beginning. I'm going to multiply everything by 3. Okay, so I'm going to multiply everything by 3. I'm going to multiply this by 3. Then this. That's a lot of distributing. This, and this. And if I just do that on the side, 3 times 2/3, 3 over 3 cancels, and it's 2. So I'm going to have 2x. 3 times negative 11 is minus 33. 3 times 64, was that 192? Let's see. Yes, 192. Maybe this wasn't the best way to do it, but whatever. We're committed now. 3 times minus 4x is minus 12x. And then 1/3 times 3, 3 over 3 cancels, is 1. So I have 3 times negative 1/3 would be minus 1x. So I did this so that we get rid of the fractions, because I think most people have like a fear of fractions. All right, so now we have minus 12x minus 1x. So we're going to have 192 minus 13x, and then 2x minus 33. So now here, we could do plus 13x on both sides. Okay, so yeah, we're going to have plus 13x on both sides. And let's see where this brings us. Minus 13x plus 13x cancels. 2x plus 13x is 15x. Minus 33 equals 192. Now we do plus 33 on both sides. This is gone. And now 15x equals 2 plus 3 is 5. 9 plus 3 is 12. And we carry the 1. 1 plus 1, first day of school, is 2. And now to solve for x, divide both sides by 15. X equals 225 over 15 is 15. So we get a nice answer here. Okay. You could have done this without multiplying everything by 3. But once again, I like to just get rid of all the fractions. If you did it that way, so yeah, I'll play the what if game. So let me erase this stuff over here and just say, what would have happened if we just kept going? So what if the alternate like universe me went a different route and was just like, you know what, I'm going to leave this as it is. 2/3 x minus 11 equals 64 minus, really what I'm doing then is 4 plus 1/3. And that's the same thing as, let me just make that neater. 4 plus 1/3 is the same thing as 12 over 3 plus 1 over 3, which is 13 over 3. So I'm just doing that part on the side because minus 4x minus 1/3 x will make a minus 13 over 3 x. Oh, wait a minute. Wow. All right. You know what? Forget everything I just said. I just saw something even easier than all of that. All right. So I apologize for not seeing this faster. But whatever. That's the beauty of math. Like, you sometimes realize like your first instinct wasn't your best. This would have been way easier. All right. Ready? I'm sorry that we all just had to go through that together. Let me just fix that. Make a nice dividing line here. So let me just first separate this. Okay. So what we should have done, or I should have done, is do plus 1/3 x first. This would have been way easier because this would just cancel. And then 2/3 plus 1/3 is 1. And you have 1x minus 11 equals this. All right, that would have been way cooler. Then you could do 4 times 16 would give you 64 minus 4x equals x minus 11. Yeah, this is way nicer. Plus 4x on both sides. I mean, the other way still works, but I don't know. I like this way more. I think it's slicker. Plus 11. All right, so now 5x equals 75. And divide both sides by 5. And x equals 15. Okay, same answer. But, yeah. Just realizing that now. So, okay. So moving on here. So we broke 2 hours. All right, but we are closing in on question 100. So those of you who just joined, thank you for joining. And remember, the PDF of these questions is in the description below. So, consider downloading it and following along. All right. So here, let's see, we have 18 minus 4x equals 8. And now we're going to distribute a minus 2. Minus 2 times 1 is minus 2. Minus 2 times 8x is minus 16x. And now combine like terms here. I'm going to leave the 18 minus 4x alone for now. 8 minus 2 is 6. We have minus 16x. So now I would do plus 16x on both sides. Get the x's on one side. Okay, this was the theme earlier, but you could see there's a lot of overlapping themes when you're doing the complicated questions. It's like basically an extension of all the simple, well, not simple, but the more like straightforward themes. Okay, like the distributive property, the getting the x's on one side, moving the constants to the other side. Like it's all your skills coming together. There's not just one nice way to do these questions. You want to start thinking of your math as like building up a bunch of skills and then being great at mixing them together. Okay, so 16x, when we have negative 4x plus 16x, that's going to make 12x. And now we're left with 6 on this side. So now minus 18. And you've got 12x now on the left equals negative 12 on the right. And we divide both sides by 12. And x equals negative 1. So 85, x equals negative 1. Cool. All right, 86. So the left side is okay. Distribute the minus 2 on this side. So we've got 8x plus 1 equals 7x, and we got minus 14 when we do negative 2 times 7. Negative 2 times x is minus 2x. Combine the 7x and the minus 2x to make 5x. The minus 14 just tags along. And now you got 8x plus 1. So minus 5x on both sides. And you've got 3x plus 1 equals minus 14. And now subtract 1 on both sides. You have to be skilled with your integers here. You've got negative 14 minus 1 is negative 15. And now you could divide both sides by 3. Remember, this is our famous, like I'm going to highlight again, earlier in the live stream, in the video, we did two-step equations. Like when I see that two-step equation, it is muscle memory at this point. Okay, not that I still can't mess it up, but like you do enough of them and it just becomes automatic. Negative 15 over 3 is negative 5. Okay, so there's like that great debate of should math be like rote memorization, like just technique or conceptual. I would argue that like the technical like memorization part, like or just the muscle memory part is so important. Like your algebra skills is just like something you have to be able to do. Like, yeah, we could talk about the concept of what this means. But at the end of the day, like to be successful with high school math and college level math, your algebra just has to be strong. Like at some points you got to stop and say, what's going on here? What's the concept? But there is a big part of math that's just like, all right, just do the math. Like you just kind of just power through and do the algebra. Okay, so that's like the theme of this video is building technique. Anyone who plays music, it's like, for like a guitarist, a piano player, violin player, or whatever, learning your scales. Like you just like, this is like you getting good at your scales. All right, it's like maybe not the most thrilling practice there is, but it's like so essential so that when you're doing the more like intense stuff later, your algebra just flies and you're not really thinking about it. All right, 87. We got a minus 3 in front of this parentheses, so I'm going to distribute that. All right. I always scan for the parentheses, and I'm like, ooh, distribute. That's usually the first step I'm looking for in these questions. So 8x. And that's at least for the complicated ones, like where there are parentheses involved. So we got minus 3 times 5 is minus 15. And then minus 3 times 2x is minus 6x. And this is equal to 85 minus 3x. Okay, so combine like terms is where my head goes next. So I have an 8x and a minus 6x. So those together make 2x. And now we have minus 15 equals 85 minus 3x. And now I would move this minus 3x to the left. Because remember the theme earlier, get the x's on one side. So 2x plus 3x is now 5x. The minus 15 just carries down. And this is equal to 85. Okay, and now add 15 to both sides. And you've got 5x equals 100. So now here, divide both sides by 5. And solution to 87 is going to be x equals 100 over 5 is 20. So x equals 20 is our solution here. So 88, more distributive property. So for this one, same idea, parentheses, I'm thinking distribute right away. And I'm going to do something a little different in this question. You'll see in a moment. So 4 times 3x is 12x. 4 times minus 5 is minus 20. Equals, we have 5x plus 2 times x is 2x. And we have 2 times 15 is 30. So once we get to this step, so 12x minus 20, the combined like term step, 5x plus 2x is 7x, and we have plus 30. Once we get here, what I will, I guess, challenge you to do is once you get comfortable with the algebra, you're like, I've done so many of these. You can do more than one step to both sides in like one. Let me start that sentence over. You're allowed to do more than one operation to both sides. What I mean by that is, let's say I want to move the 7x over. I could go minus 7x on both sides. But then all in one line, I know I'm going to have to move the 20 over, the minus 20. And I'm going to move it over by doing plus 20 to both sides. So you are allowed to do 2 steps of algebra in one line. So this, though, I only recommend you do once you're comfortable. Okay, because when I do these on my own, I usually do 2 steps at once. Like, you know, or sometimes more, depending on like the question. So minus 20 plus 20 is gone. 7x minus 7x is gone. And we got 12x minus 7x is 5x. And this is equal to 30 plus 20 is 50. So you see, it just gets you to the end a little bit faster. All right, now I'm not telling you to skip all your steps. Oh yeah, and we divide by 5. 50 over 5 is 10, so x equals 10. You know, I'm not going to tell you to skip all of your steps because I equate like skipping too many steps in math as like eating a hamburger. Like if you're like, oh, should I just do it in one step? That's like trying to eat a hamburger in like 1 or 2 bites. Like you're more likely to choke. So you show work the appropriate amount. You know, you don't want to skip too many steps, but if you go like too slow, like your page is going to be that long. So as you get more comfortable, you could kind of start to do more in one step. All right, but that's up to you, like when you're ready. All right, this one here, no parentheses. Okay, so this one just combine like terms. 3x minus 5x is minus 2x minus 12. And then here, these are the like terms. We'll do this in a different color. We got minus 85 minus 5 is minus 93. Okay, so that's going to give us 7x minus 93. And now, you know, get everything, get the x's on one side. So we'll practice that thing I said before. 2 steps in one. So plus 2x on both sides. And then in a moment, I'm going to move that minus 93 over, so might as well just do it now. Plus 93. So this is gone. This is gone. And now if I do that off to the side, 93 minus 12 is going to give us 81. So we have 81 equals 7x plus 2x is 9x. Now divide both sides by 9. And x equals 81 over 9 is 9. So 89, x equals 9. All right. Question 90. We are making it to the final stretch here. So let's see. We got to get to 100. All right. So minus 3 times x. We're distributing. We have minus 3x. Minus 3 times 6 is minus 18. Equals, we have x minus 1 plus 8x. So combine like terms is the first order of business. So we got 5 minus 18. So this part I'll just bring down here. This is minus 3x. And then 5 minus 18 is going to give us minus 13. Okay, I'm just thinking off to the side here like, oh, 18 minus 5 is 13. But the positive number is smaller, so it's going to be negative 13. Okay, like when you just flip this, like instead, it just changes it by the sign. It just becomes negative 13 when you do 5 minus 18. Okay, now equals, and this part we have an x. This is a 1x plus an 8x is 9x. And the minus 1 just tags along. So here, we'll do plus 3x on both sides. And this is gone. Minus 13 equals, we have 12x minus 1. And now add 1 to both sides. And you've got negative 3 plus 1 is negative 12 equals 12x. Divide both sides by 12. And x equals negative 1. Okay, so 90 should be x equals negative 1. All right, the final 10 questions will be literal equations. So we made it to the final 10. So here we go. Solving for x. Still, it's 3 times x equals b, where b, all these non-x's are just representing some constant here. Okay, so divide both sides by 3. And this will give you x equals b over 3. Okay, so literal equations bother people, but it's still like the same idea. What's annoying about literal equations is like you can't simplify b over 3. Like b, like let's say b was 9, then 9 over 3 is 3. But we don't know what b is. So nothing simplifies. Okay, divide both sides by k to get x by itself. And we'll say x equals 8 over k. Now, one thing I'll mention here, we'll just say k can't be 0. Okay, because if k is 0, the universe implodes. We can't divide by 0. All right, so k is not equal to 0. I'll just mention that anytime it's appropriate. All right, so here, now we're going to solve for x. We're going to divide both sides by r. And we'll say x equals w over r. They're both constants, but the restriction here, once again, dividing by 0 is not allowed. That's something you explore more in like pre-calculus, calculus. So r, in this case, can't be 0. Okay, otherwise dividing by 0 is no good. Okay, so this one, there's not going to be any restrictions because it's just addition. But we're solving for x. There's a plus c attached, so I'm going to go minus c. And notice that these are like terms. This is saying basically 8c minus 1c is 7c. Okay, so x equals 7c is 94. All right, 95. Solving for x. So now it's getting a little more complicated, but x is over here. So we just move everything away from it. So plus w first. And this is going to give us cx equals 4w plus 1w is 5w. And then we'll divide both sides by c. All right, so we're saying here x equals 5w over c. But one thing I will mention here, once again, c can't be 0 because you can't have a denominator equal to 0. Okay? Hang in there, Ryan Tube. The grade will be there. I know you're very anxious because you want to see how you did. I hope you got that 100. I really do. I'm rooting for you. Fingers crossed. So let's see here. We're solving for x. And we're going to get the q to the other side first. So minus q. All right, so now q minus q cancels. We have px equals y minus q. Divide both sides by p. And now we're going to have x equals y minus p over q. I'm just going to, once again, make mention here, the denominator, if we're solving for x, we're going to say here that q should be non-zero. Okay, x equals this would work out, but once again, we can have a denominator of 0. Okay, so next part, 97, solving for x. And now, if you notice, we have x's here and here. So get them together. That's part of the process here. So we're going to go plus 7cx on both sides. So plus 7cx. And now think of this as a 1cx. That's going to give us 8cx plus c squared is equal to 5c squared. So now I'll go minus c squared on both sides, because once again, the goal is to get x by itself. The thing is, I know you're saying non-linear, but we're going to say here, like c is a constant. Okay, so we're treating c as a constant, not like as a variable for these literal equations. So c squared is like still a constant. So it's not like we're going to need to factor or do anything crazy like that to solve here. Yeah, so I found this, what's it called? I found this like in like a linear equations section. So it's like, I know what you mean. Like the fact that there's a square involved, like, oh no, but like we're solving for x and x is only to the first. So it's, yeah, like just makes the cut. So 8cx equals 5c squared minus 1c squared is 4c squared. All right, and now we divide both sides by 8c. Okay, and this is going to give us x equals. And notice if I leave my answer like this, I still have to mention, like, we're dividing by c. So I'm just going to mention here that, like, c is non-zero. Okay, because that will, yeah, that will, like, kind of mess things up here at this dividing step. All right, like, it could kind of bend the rules a bit. So here, we have c squared over c. I'll just write it like this. This is 4 over 8, and c squared is c times c over c, like this. So the c over c cancels. 4 over 8 reduces to a half. So now this will give me x equals, and I have just c on top over 2 on bottom. So 97 is x equals c over 2. All right. So here we go. So moving on like this. Now, I just want to think of... Yeah, no, I'm just thinking out loud. All right. So let's see. For this part here, for 98, what we have, we're going to add 3n squared to both sides. And now this is going to cancel. We have n squared x equals, and we're going to have 12 plus 3 is 15, n squared. Divide both sides by n squared. I'm going to mention here, n is non-zero because we're dividing by n squared. So 0 squared would be 0. The squares cancel. X equals n squared over n squared cancels. X is equal to 15. Okay? Cool. All right. One thing I want to explore a little bit more here, though, is that if c were equal to 0, we get 0 plus 0 equals 0 minus 0. So why is this... I mean, I would say here at this step, c over 2. Let me just see why. I'm going to check. This one, I'm like, you know what? Let me just plug in and see what happens here. So I'm going to check this one. I know I'm kind of like going backwards here, but that was just on my mind. So c times x is c over 2 plus c squared is equal to 5c squared minus 7 times c over 2. So this would give me c squared over 2 plus c squared equals 5c squared minus 7 times c is c squared over 2. And why is this? If c is equal to 0, is this a problem? Because to solve for x, we divided by 8c. I'm just trying to see if c equals 0 is really an issue. I guess like funky things could happen here with other values of x, because x could still be anything. So if c is equal to 0, does that change? So let's see. 1/2 plus 1 is 1 point. So this is like, yeah, 1.5 or, yeah, 1.5 c squared equals. This is 5 minus 3.5, so 1.5 c squared. So is this, because see how there's, in this case here, the denominator doesn't have a variable. It's just a constant. But we did divide. Like once we're in this form here, 4c squared over 8c. Yeah, technically if we leave it unsimplified, c equals 0 would make this undefined. So I still feel okay saying this. Because, yeah, technically at this step, this is kind of going off on a tangent a little bit. But I just want to mention something here that, like, you know, when you're in Algebra 1, solving equations, like you could have x squared over x is one function. And then, like, g of x is equal to x is another. And then people ask themselves, like, oh, is f of x equal to g of x? Are these equal? And the answer here is no. They're not, because f of 0 equals 0 squared over 0 is undefined because you're dividing by 0. So f of 0 in a situation like this is undefined. So yeah, that's why, like, if we left our answer unsimplified, 4c squared over 8c, c equals 0 would still ruin this. So the fact that it cancels is just like, I feel like it's sloppy to not mention this. But yeah, I just didn't want to leave that uncovered in this video as to why I'm saying here, like, c is non-zero. All right. So yeah. Okay. So same idea with this one. Like, we're dividing by n squared, so like technically, like, our constant shouldn't be 0 here, because it like, I know it technically wipes out everything in the beginning. It's just sloppy to like ignore this fact. All right, so question 99, we're almost done. 2 more questions. So let's see. X is on both sides. So I would get them on one side. So plus 5cx. Now, this one is when things start to get a little wacky. Of course, we have to end in style. So we'll have 8bx. We'll have plus 5cx. And then we're going to have minus 7b squared is equal to 19c squared. So here, what you'll notice, we have matching x's. So now it's going to involve a step of factoring. Like, when you think about like something like, let's say, 2x plus 7x. I'll just draw this off to the side. In your head, you probably just know that that's 9x. But what's actually happening here is, like, you're factoring out the x, and you're doing 2 plus 7. It's like you're doing the distributive property, but backwards. So that's kind of what I want to express over here, that this is 8b plus 5c. Like, we're adding the coefficients, and then we're combining it into a single x. And now minus 7b squared, okay, equals 19c squared. So now, to solve for x, I'm going to move this out of the way. I'm going to move that over. So we're going to have plus 7b squared on both sides. Okay, so this will cancel out. And now we're going to have 8b plus 5c times x equals 19c squared plus 7b squared. And now here's a dividing step. So to solve for x, now we just divide by this entire expression, the 8b plus 5c on both sides. So 8b plus 5c. And I don't have to put parentheses on this side. I'm doing it on this side so we can see the factors canceling. So now we get our solution, x equals. So question 99 here, we're going to have 19c squared plus 7b squared over 8b plus 5c. Okay, and one thing I'll mention here is that the denominator, the 8b plus 5c, is just non-zero. Okay, so that's just one thing here to mention. The denominator is not, for when the denominator is non-zero. All right, final question. So we made it to question 100. So I'm happy to have you all here with me. We broke 100 people for the live stream, which I'm happy to have every one of you who joined me here. So let's go ahead and do this. So this is w over 1, and we will cross multiply. So we have w times kx is wkx equals 1 times this is just whatever we have there. So remember, get the x's on one side. So we're going to get these terms together. So let's go ahead and do that. We're going to do plus 2x on both sides. And now this is gone. You have wkx plus 2x equals -3. And now, same idea as before, factor out the x. So we're going to have wk plus 2 times x. Okay, you could even see if we distribute, we would go right back to this. Equals -3. And now divide both sides by wk plus 2. Over here it cancels. And finally, we get our last solution here. X equals, we've got -3 divided by wk plus 2. And we will mention here that our denominator, wk plus 2, cannot be 0. All right. So that is it. We made it through 100 questions. All right. So, yeah, thank you to everyone who sat here with me. for all or part of it. It would be a tremendous ask to ask anybody to stay here for 2.5 hours. But thank you for being a part of this. Let me know which of the questions or questions did you think was the toughest, and reflect on this with me. Like, there's a lot to be gained, I think, by doing these questions. If I'm brutally honest, like out loud, because I'm doing these questions like live, and I'm looking at some of these questions and I'm thinking about like the dividing by the constant step here. Yes, that as long as the coefficient here, like for n, is like not 0, like it's not technically like -3 times 0 squared, I guess that would like make it okay. Like if we think about it here, if I had like, 0 squared times x equals 15 times 0 squared, I can't just say this like, oh yeah, divide by 0 squared. Like that wouldn't be allowed. Okay, this is like no, like don't do this. Like you can't. Like this is not allowed. So thinking about this more, I'm like now happier with like the idea of mentioning that like, oh yeah, the number we're dividing by here can't be 0. That's just not okay for us to do. So we just have to omit that case. All right, because if you want to know a little bit more about that, like, so a little bit of a tangent here, and let me maybe mention that in the other section over here, so we could stare at that 100 again, that we made it. The reason being why you can't divide by 0. So why is that not allowed? Well, just know 1 times 0 equals 0. And you would agree 3 times 0 equals 0. So if I was allowed to divide by 0, so this is like, why can't we divide by 0? Because then you could say anything. You could make anything up. Right? If I'm allowed to divide by 0, like let's say we were, then 1 is equal to 0 over 0. And 3 is equal to 0 over 0. So it's like, 1 equals 0 over 0, and that's equal to 3. So the transitive property will tell us that 1 equals 3. And it's like, no, not allowed. Okay, so you can't do that. All right, so that's why, like, sometimes, like in algebra, they'll glaze over that. But I think it's something that's important to think about. All right, so that's something that when it did show up, I was like, like dividing by 0 is just not cool. All right, awesome. Oh, Fortnite, Sweaty Kid, hello, nice to see you. But yeah, that is the 100 questions. So thank you all once again. I'm just happy to have been able to do this, and I appreciate the support. And yeah, stay tuned for my next video or live stream. If you got any requests, just let me know in the comment section what you'd like me to make, and I will add it to the queue. So thank you and take care.